Okay, good morning, Monday. Goodbye, Monday. Those of you, Jae, come sit a bit closer because I might draw on and write on the board a lot today, so want you to be able to see clearly. Net as well. Stop playing with your phone. Okay, what's the topic today? Concurrency. Shh. So before we talk about the lecture today, perhaps I'm going to start talking about the team members. I'm sure that you guys have seen your team members now. Yeah, happy with our arrangement? Quiet, so I still can't get your attention. How about the fact that we will be posting the group project pretty soon? Imminent. Still no response. This class, this room, actually I'm very familiar with it because it's the class that I taught Intro to ICE the last semester. So this room is actually quite special. Not in this semester. Not going to happen this semester. Anywho, so, all right, I'm going to get started. The topic that we're going to be talking about today is about concurrency. And when you hear the word concurrency, what are the tools that you have learned so far in this semester that facilitates concurrency? Thread. Is there anything else? Wow, we picked the wrong day. Should have picked like Tuesday afternoon or Monday afternoon, Tuesday morning, right? Not Monday morning. Where did you guys go last night? Where did you go, Em? I didn't see you. I didn't see you come snooping around my house last night. I was kidding. All right, so concurrency is about threads, okay? More or less. But you'll learn today that actually concurrency does not equate to threads. It actually includes other tools that you'll be learning about today. So what was the kind of application that we used threads for? Ping? So what did we use threads for so far? Come on, Pink. Threads. You don't remember? On the midterm you did pretty well. Oh my God. So who can answer me or who can tell me what did we use threads for so far in this class? Oh, hold on. Let me count how many people are not wearing their uniform today. You guys are going to be the target. Why is it so hot in here? Is it a bit hot?
Yes.
Because I guess you'll get picked on today too. Oh yeah, you will. Because so there's 1, 2, Ja as well. You as well. So I have 4 targets to pick on today, primarily. It's a makeup class, but you guys still have to wear uniforms. Today is not Friday, okay? You don't have anything to be afraid of anymore. Okay? All right. Animation, the key is animation. Right? That's what we use the threads for. Do you guys remember the animator design pattern? You said we need threads to run program.
No, I said animation.
No, but I was asking somebody else, but no, I mean, I know you know the answer, but I wanted to get other students involved. Ja, I thought you were going to come sit in front. Oh, okay. All right. So I want you guys to keep those in mind, all right? First is that we've learned threads already. Okay, so we're not going to be covering, when you extend, okay, when we extend threads, what are the requirements, what are the implementation requirements? We're going to touch roughly on the application of threads. And secondly, I want you to pay attention to the application, why we need concurrency, okay? Okay, let's get started. So before we begin, I'm going to briefly go over what we plan to cover today, okay? I'm going to first try to define concurrency in a simple term without trying to sound all theoretical. And I'm going to try to have a motivating discussion as to why we need to study concurrency. What kind of problems does it address? And how does it make our lives easier? And then we're going to dive into Java tools. What are the available tools provided by the Java framework, starting from pre-Java 5 and covering all the latest tools up to and including Java 8, 7 or 8. Now, what is the current version that you guys are using right now for Java? 6. For this assignment, you are free to use, for the homework assignment, you are free to use any versions, okay? You can use Java version 5, 8, I don't care. And you can download libraries to do the homework as well. The point is for you to, get a taste of what it's like to develop a multi-threaded application. And if you don't want to use any tools or libraries, that's fine with me. If you want to roll up your sleeves and then implement your own threading solution, that's okay. But you will be spending quite a lot of time on this homework if you did that. And then we're going to be looking at common design patterns. What's a design pattern? What's a design pattern? We've covered, I think, 1 or 2 maybe in this class. I don't remember. But what's a design pattern? Can someone help me? What is a design pattern, or why is it that we should study design pattern?
It's a standard way to write a program.
Right. It's a tried and tested way to write the program. What is the motivation behind it? Why do we have to care so much about, okay, it is a standard way to write program?
Code reuse.
Code reuse, okay. What problems does it help solve, design pattern? Okay, we'll be talking about it.
Save time.
Save time. Okay, so, I'm going to be talking about it again, or redefine it again, but, the gist is that design pattern gives you a solution to solve common design problems that you run into when you design object-oriented applications, for example. And when you follow the recipe or the design pattern, it can actually offer you the optimal solution so that you don't have to try to come up with the solution yourself. Okay? And it might all sound abstract right now, but that's okay, because the design pattern that I'm going to show you today, I think once you see it, it should make a lot of sense. As to why, how can you implement it any other way, right? And then, the next thing is advanced topics. So towards the end of the lecture today, I'm going to be covering just the new developments in the concurrency world. Okay, these topics, I don't expect you to, there won't be homework assignment for these topics, but I thought of covering them anyway. Okay. because I think they're useful concepts for you to know. And I have a hunch that by the time that I get to advanced topics, I'll run out of time already. We'll not have enough time to cover them. And that's why I said that it might be possible that I ran out of time, so I don't have time to cover those topics. Okay. Concurrency defined. So let's talk about concurrency defined. What is concurrency? So when you think about concurrency, I want you to think about the animation that you did. Okay? It might not sound like or look like it, but there actually were two threads of execution going on when you did the animation, right? There was the animation itself that was actually being animated. The other part was the main thread, which just sat there and didn't do anything. So what is the key? Whenever you have a concurrent program, it is a program that contains parts which run concurrently. Okay, and that's the key. And the reason why I included that diagram is because if you read the entire sentence, concurrency occurs when your program contains parts which run concurrently. There are two concurrent words in the sentence. So it's sort of like a recursion, and that's why if you look at the image, the meme down below, it's like, hey, I heard you like processors, so we put processors in your processor. You can process while you process. So it sounds pretty, that's why I put the image there, okay? So I hope that on the final exam, if I ask you what is concurrency, you would be able to tell me or define what concurrency is. So again, concurrency is simply just whenever your program has parts of the program running in parallel, running concurrently, okay? Oh, so for those of you who are interested, I'm too lazy to do it. There's actually a history behind the image from the previous slide, okay? And those of you who printed the lecture slides out, if you wanted to just check out the history, by all means, just go ahead. There's actually a reason. So it's not like some random text. This guy just likes to say sentences like this that put multiple, like the same words into the sentence. Anywho. Okay, so why are we studying this? I think I've already started to talk about the motivation behind multiple threads, okay, in the first slide. So I'm going to skip quickly on this, but what I'm going to focus on is why are we studying this? You guys have to understand the benefits of having concurrency in your program first before you can learn about the tools. So motivations, right? What are the motivations? Can someone tell me, based on your experience with animation and threads, creating threads on your own, and having gone through the exam, can someone tell me why is it that we use threads? I'm looking for 3 reasons. I normally play this clip a lot. Hey. But then I can't find it. Anyway. So what are some of the benefits that come with using multi-threading in your application? Halin? Huh? What? Oh. Oh, come on, I want you to help your friends out. Oh, I have a new target too. Can you tell me, whoa, what the heck's going on?
third test at Mohali in a startling
Mohali. So we what? What's wrong with? What are some of the benefits of using threads in your application? My computer is frozen now. Yeah. And you know why I picked on you, right? Not because you came in late. That's not the class policy.
Well, someone told me I can wear anything.
Really? Anyway, just go along. I mean, you're supposed to know this anyway. So why do we use threads in our application?
So we can like animate the object we want to.
Right. That's the first, I mean, that's a good answer, right? Because that's what you use threads for in this class. But what's unique about threads? We've already defined concurrency, right? So so let's think about this. If we define that threads simply allows your program to run concurrently, then what is the benefit? Multi-threading, right? But think about it. Why would you want your programs to be able to run concurrently?
To be faster.
Okay, faster how? Why would it be faster when you're able to run parts of your program at the same time?
Because we can do many tasks at the same time.
Okay, so I think that's a good, right, that's a good benefit, right? I mean, first, the benefit of multi-threading is that since you can run multiple parts of your program concurrently, then that means that you can do many things at the same time. I mean, think about your smartphone, for example. Pick the iPhone, right? How would you like it if you can only do one thing at a time on your phone? And by one thing at a time, here's what I mean. I mean, we all do one thing at a time, right, on your phone. But what if while you're doing, I don't know, making a call, you can't receive any messages, your WhatsApp or your Line, right? Or think about when you're browsing on your phone. What happens how would you like it if while you're browsing your phone on the internet, you can't take any calls? Would that be good? What if there were emergency calls, right? So that's the first thing about multi-threading is that it allows your program to do many things all at the same time. So in other words, the keyword is multitasking. It allows your program to multitask. Is that clear? So Phon, what is the first benefit of multi-threading? Oh my God, I just said it. Wow, you guys, Tato, can you help her? I just said it right now. What are you guys doing today? Multitasking, what is multitasking for? It's not enough just to tell me the term. What is the definition of multitasking? Like why do we want to multitask? Why do we want the program to multitask? Right, thank you, Ping. No, you guys, I mean, if you guys don't want to cram for the final exam, you guys should pay attention now, right? So multitasking is one, okay? And Bod, you mentioned that the program will run faster too, right? So secondly, I think, in my opinion, is that because you can multitask and because you can coordinate the threads to work together to solve a particular problem, sometimes on occasions where it is applicable, you can actually make your program run faster as well. Okay, that's the second benefit. So first benefit, the keyword is multitasking. The second benefit, is he violating the rule too? And the second benefit is performance. With multi-threading, you gain performance. And the third benefit that I will cover later, which might not be so clear. And by the way, for those who printed out the lecture slides today, just 1, 2, 3. Oh, only 3. Wow, that's surprising. 4. No. Oh, okay. You're looking. Okay. What I meant to say was that the answers are already on the next slide, right? So you could have. So we've covered multi-core. Okay. First thing I wanted to talk about trends. I forgot to talk about that, but what might not be so clear to you guys as a third benefit is that with threads, you can actually simplify your program design as well. And we'll see how you can achieve that. But for now, I just want to cover like the benefits. So let's talk about the trends that we have currently in the industry, in the consumer market. Who here has not heard of the word multi-core? Are you guys aware? Stuck in my track. So you use the MacBook Air or the 13-inch side? I know it's Retina, but is it 13-inch, the MacBook Pro, or is it the Air? Okay, MacBook Pro, right? Can you Google on your right now, how many cores does your 13-inch have? 4? No, i5, just because it says i5 doesn't mean that they have 5 cores. Oh my God. Okay, 2 core, 4 threads. But that's for your machine. I want Sign to look up.
But sign have 32 cores.
I only see she only have 1 core. Multi-threading, multi-core. So with the exception of Sign, anybody else has heard of the word multi-core? Please raise your hand. What? Are you kidding me? You know you guys should have taken Intro to ICE with me. Because all the students in my class, they know what multi-core is, and they also know that i5 does not equal to 5 cores. Okay? You guys should have taken Intro to ICE with me. We went through basic computer architecture. Man, I will not allow you guys to graduate if you guys don't know what multi-core actually is. Come on, man, you guys are ICE, okay? Okay, the Frenchies. Do you guys know what multi-core means? No? Oh my. What is this, man? Jae, you know? Multi-core? Yeah? So what's the definition of multi-core? So now I'm really concerned. Many core, no, we all just have 1 core. Okay, it's many core, but what does that mean? No, I'm not gonna ask Niran. Tong, what is multi-core? What does it mean?
Many processor in one processor.
Yes. So that's the change, right? Okay, that's the change. First of all, is that multi-core is now ubiquitous. It's everywhere. All the new computers these days, all the consumer computers these days are shipped with at least 2 cores. It's multi-core, right? And if we were to write our programs the way that we normally do, which is to have just a single thread, like in other words, there's no threads being used at all in our application, what do you think is the effect? Are we fully leveraging the hardware changes that's occurring today? In other words, okay, I'll just say, if you're still writing single-threaded application, you're not leveraging the multi-core architecture provided by the computer's hardware. Even the S4, I found out from one of my students, Tino, that the S4 came out, a couple of days ago?
Yeah.
How many cores does that have? 8. See, that's the Google ambassador. Yes, we are going to have 8 cores. Wait, is that right? I don't want to be misquoted. Right? Huh? Well, how about this? I know at least it has 4 cores. At least. Right? The S4 has at least 4 cores, and I think it has 8 cores, if I remember correctly. Okay, to digress a bit, what's the screen dimension for the S4? Did you hear that, you iPhone iPhone users? 5 inches. About time you convert. So even your smartphones have multi-core architecture. And if you're going to still be writing applications, okay, a single-threaded multi-application, you're not taking full advantage. You're not exploiting the architecture that you have. Because why? Why do we care so much about having to fully exploit the hardware capability? Imagine using your phone, right? You play your latest game. What are some of the factors or some of the causes that might cause you not to want to play the game anymore? Lag, right? Lag time. If the program suddenly freezes, okay, when you're doing shooting someone, it could cause you to lose life in the game, right? In the game. So performance is a concern. So how does that affect us as application developer? Well, if your users are frustrated when they're using your application, what's going to happen? They won't buy it. They won't use it. And then from whom are they going to buy it from? The game. Your competitor. So you end up not getting any money, and then you spend all that time developing the next generation game that you want everyone to play, and then in the end they end up not playing because you didn't take this class. Well, I just meant that because you did not fully exploit the hardware architecture. You did not use all the resources. So that's one of the trends that's been changing, and this is why we're teaching you multi-threading. This is why we're teaching you about concurrency, so that your skills will be up to date with what's going on in the industry. And I unintentionally talked about consumer behavior. So what are the consumer behaviors today? Actually, let's not talk about consumer behaviors. When we're talking about consumer behaviors, you guys are the representative of today's consumer behaviors. When you use an app, what do you expect? What are your expectations out of apps that you purchase or you use? Huh? Okay, it should not crash, right? First of all, and we'll look at tools today that will see. Let me skip ahead just a bit, but the difficulty of developing multi-threaded application is that, well, right, so you gain better performance if you do it right, but the trade-off is that your program will also become much more complicated, okay? And you'll see examples today. So when it becomes much more complicated, what is the effect on your code? It's harder to develop, right? And thus, you can run into problems. So when your program runs into problems, most of the time what happens? It crashes, okay? So first of all, coming back to the main point, first behavior, the first behavior you want is that you don't want the program to crash. Okay, what are some of the other reasons why you want to use an app? It's free, okay. So doesn't crash, free. What else?
It's answer you need.
So it fits what you want from an app. But think about it, hold on. Let me think about what are some of the, I don't know, Instagram, for example. Like, why do you use Instagram? So some applications look really nice, right? How would you like it if, I don't know, your Instagram app looks like it was built in the 1995? Also, I guess that's the new consumer behavior. Like you guys have different, right? So you guys want applications that look good, perform fast, right? And then doesn't crash, so reliable, right? So these are the current consumer behaviors. But the consumer behaviors I want to focus on that I want to get across today are two things. First, you want a reliable application, okay? And secondly, I think you guys all want applications that are snappy, you know, just like that, instantaneous. Like say you run your application, it should show up immediately. And this was one of the reasons why I rooted and installed, what is it? CM or something? CM ROM on my S3. Because I got fed up with the original ROM, and now that my phone has been rooted, it's much, much faster. It's now snappy. So for those of you S3 users out there, if you have trouble or are frustrated because your phone is slower than the iPhone, then one possible solution is to just root your phone and then install a new ROM. And I use CM. Okay, so consumer behavior, two things. Reliability, right? Program to be stable. Secondly, performance. We want it to be fast. Characteristic of modern hardware. So I've already covered the characteristic of modern hardware and software. Is that if you notice, all applications, all electronics, these days, they can multitask. It doesn't matter what we're talking about. They all multitask. Think about your phone, right? We already talked about how it multitasks. Thinking about your computer, you can run multiple applications all at the same time, right? And many events going on, your Wi-Fi, your clock, whatever. All these are possible because the concept of concurrency, okay? So we have already covered most of the slides here, but I want to go over them again just to ensure that you guys all understand. So on the left-hand side, we have what we call the Windows Task Manager. Who has never seen the manager before, the task manager, on the left-hand side? You guys have seen. So, Mil, how many processors are there? Hi. Is your name Mil? I'm going to pick on you all the time now, Em. How many? Oh, we know. How many? 4. How come you said 4? You didn't sound very confident. Well, for those of you who have not used the task manager before, let me see, I can use my mouse pointer. I can't. But anyway, right underneath the CPU usage history shows you the number of processors that the computer sees, or not, that the operating system sees, okay? So in this case, we have reasons to believe that there are 4 cores on the machine, okay? So how concurrency helps is that if you program your application correctly, instead of seeing the first core being utilized 100% of the time, with multi-threading, then you might see all four being utilized at 50% or 75%, or in the best case, 100% if you have really computationally intensive application. This is what we mean by leveraging, fully leveraging the hardware, the multi-core architecture. And we've already discussed, if you program your multi-threading application correctly, then you would make your program faster. And we have concrete examples today to show you that multi-threading program, if applied correctly, as in applied to the right problem, as well as done correctly, then you can actually speed up your application. So let me explain a bit more on what I meant by if you apply to the right problem, and if you did it correctly, then you will get the speed up. Because first of all, multi-threading is not silver bullet. By that I mean, just because you use multi-threading in your application doesn't mean that it's right for your application, and secondly, does not mean that you'll get speed up in your application. So let me give concrete example right now. If I ask you to write a Hello World program, do you think we would need multi-threading for that problem? No. Why not? There's only one task. Oh, thank you. That's a very good answer. There's only one thing to do, right? We only need to print out something to the screen. Why would you want multitask, or why do you want to multi-thread that? You don't. So this is what I mean by if you apply multi-threading to the right kinds of problem, okay? And secondly, what did I say? What did I say, Nit? You were dozing off. You were looking at me, but you were really not looking at me. What was the second thing I said? Ping, help. You can whisper. I'll pretend not to look. So I said first, I said if you use multi-threading and you applied it to the right problem, okay? And secondly, I said something, then you'll get a speed up. No? So who can help me? What did I say? The second point. Okay, it's performance, but if you did it correctly, right? I said, so if you apply it to the right kinds of problem, and if you did it correctly, by correctly, here's what we mean. Now I'm at a loss for a concrete example, but just if for example, if your program had, I don't know, this is a bad example, I'm sorry, but if your computer that your program that you're targeting has 4 processors, multi-core, 4 processors, but you only created 2 threads to help you solve the problem. So you get a speed up, but it's not fully utilized, right? Because you were supposed to create 4 threads to fully utilize the hardware. So you're only getting 50% improvement as opposed to 100% improvement. That's sort of like a bad example. I can't think off the top of my head right now. But you get the point. The point is to ensure the proper speed up, you must apply it to the right problem, and that you must do it correctly. And we're going to teach you how to do it correctly today. And lastly is design simplification. What do I mean by design simplification? So I have here an example of the next generation iPhone 10, right? So how many apps does it have? A lot. You can say a lot. You don't have to tell me the exact number. But imagine, okay, if you were tasked to write the operating system for the iPhone 10, okay? Imagine if you had, without giving multi-threading as one of your tools, how would you design the program to handle multiple inputs and outputs that's going on the phone. If I did not give you multi-threading as a tool, it would be a very hard problem, right? Because you see, essentially, all multi-threading problems can actually be done sequentially as well, or without multi-threading, because then you essentially have something like this. While my app is running, you handle multiple events, all in one big block loop. You check, okay, so is someone calling me? Okay, no. Then I move on to the next task. All right, well, is the internet still on? Do I need to check for messages? Okay, good. There's nobody calling, there's no messages, so I'm gonna skip to the next task. Then you check like, oh, so is the current application that the user is currently using, do I need to do anything? But you see, the problem with that is that there are countless possibilities of the tasks that your program, your operating system has to manage. And imagine you have to write a program like this. There's no modularity, right? There's only a single thread that handles everything inside your phone. Is that a good design? No, right? I mean, ideally, okay, if these three tasks are independent, what do we mean by independent? How do we determine? This is actually a key for your homework as well. How do you determine whether or not two tasks are independent? By two tasks, I mean just anything you want to do with the application. How do you know that two tasks are completely independent? Now, here's a motivating discussion or example. So this is task 1. This is task 2. Compare this. Okay, you know that all programs, all meaningful programs, have what as its component? Input and output. See, regardless of what architecture you're talking about, at the end of the day, every single program is composed of input, processing, and output. Okay? More or less. We say that two tasks are independent, okay, by one definition, if the output from one task does not need to be fed into the input of another task. Right? Do you agree? Why is it that when I say, let's take the phone example, the feature of making a call and the internet, are those two tasks or functions, are they related? Making a call and using the internet? No, right? They're not related. Because you don't care when you make a call, you don't care about the internet, and when you use the internet, you don't care about making the call. Because the input and output, they're independent, right? Can someone give me an example, because I can't think of one right now. But can someone then, knowing that definition, then can someone tell me what are some of the examples of tasks that are actually dependent? Anything. I have you too as another target, not Pink, but the guy in the back. You're not wearing your uniform. Wow, I have many targets today. I can't think of one, but you get the point, right? I don't know if anyone can give me an example, anything that depends on one another. Two tasks. If you had the output of this going into this, if you needed to do that, then we say that those two tasks are dependent. And because they are dependent, you can't really break them up into multiple threads. So, but if you have something like this, where T1 is totally independent of T2, for example, like making a call and using your internet browser or whatever, then you can put this in some thread T1, right? And then this can be inside thread 2. And they all can have their own while loop. You guys remember the while true loop, right? Yeah. So it's really simple. I mean, we're not talking about like rocket science here, right? So that's what I mean by design simplification. With multi-threading, you can then split up your program from having like just one big gigantic while loop and separate them into different threads. So this task goes on T1, this task goes on T2, this task goes on T3. And because you can split them up, you can delegate each of the tasks to each of your developer. You might ask Dong to work on one part of the program. You might ask Pi to work on another part of the program. These are all the benefits of multi-threading. You can make your program more modular. Is that clear? Good. Wow, I spent an hour on that? Okay. So now I'm hoping that by now you guys are all convinced of why we need to use multi-threading. Okay? And I hope that you guys see the benefits, okay, why we want to use multi-threading. So now that I assume that all of you guys see the benefits, see the reason why we need to use multi-threading, then I'm going to be talking about tools that would allow you to achieve concurrency in your program. So the first tools that we're going to be talking about today are what we call, in the present day, primitive concurrency tools. By primitive, right, we mean something that is from an early stage in the evolutionary or historical development of something. And I would like to emphasize early stage in the development of something, because the primitive tools that we're going to be covering in the next few slides, these were the tools that were created prior to Java 5. So that's many, many years ago. And there's nothing wrong with them. It's just that with primitive tools, right, you can only do so much. But with modern tools, then you can do a lot more. But why do we need to cover primitive tools? It's because they serve as the building blocks for all the concurrency, all the modern concurrency tools that we will see down the road in the later slides. Without the solid understanding of primitive tools, you will not be able to use the modern concurrency tools effectively. This is why we need to study primitive tools. Mil, why do we need to study primitive tools? Hey, you're not talking to the computer, you're talking to me, so I couldn't hear you. You're suddenly quiet now because last time I met you during the office hour, you were so loud. So what did you say? Oh, wait. So what did you say? Okay, that's fine. Pan pan. Okay, at least you got that part. So who can answer me before I move on? Why do we need to learn about the primitive tools? Milan.
So it helps us to work with modern tools better.
Yes, because the primitive tools are the basic building blocks of the modern tools, and once you master or you have a good grasp of primitive tools, you can work with the modern tools more effectively. So the first example of such primitive tools is threads. You all have used threads in this class. whether it's directly because you did the homework yourself or indirectly because someone else did the homework for you, you all have more, more or less used threads. On the exam too, right? Even though I asked you to subclass the thread and you did the implements runnable, you more or less have used threads before. And can you please remind me again, what kind of application did we use multi-threading for in this class so far? No. So what kind of application did we use multi-threading for in this class? Can you be a bit more, can you generalize that and not just say the digital clock? Oh. Huh? Oh yes, thank you, Ploy. I heard your answer loud and clear. So now I know the tricks. I understand your behavior now. Even though you might be looking at me, but you might be thinking about like the guy sitting in front, or even though you're looking at me, you might be, I don't know, daydreaming about something else. So now I know that even though you might be looking at me, I still should pick on you because you might not be listening. Okay, so since I get answers like what kind of applications we use multi-threading for, and I get answers like digital clock, this is why I've prepared an example of how one would use threads in the application. So let's take a look at this application, which I appropriately name it the Lover app. So I don't know, I just picked some names, okay? I just picked some name. So let's say we had two lovers. I just picked some name. And the names are like Nat and Ploy or something like that, right? And that's digression, not related to the current topic. So, all right, so what's the objective of the current program? Well, as you know, when you are lovers, right, your bank account are separated when you're lovers, right? And you know, the two are going out tonight. I don't know, going to see a movie or something. So Nat has his own account, and he has 10,000 baht in his account. And Ploy also has 10,000 baht in her account, okay? And Nat is a boyfriend, and Ploy is a girlfriend type. It is a type. Right there, right? New boyfriend, and then you pass in Nat's account, and then new girlfriend, Ploy account. It is a type. I mean, and then you guys know that when we do a start on something, most of the time it means that we are initiating a thread, right? So let's see if that our suspicion is true. So boyfriend is a human, and that extends from boyfriend is a human, extends from human. So let's see what is a human. A human is a thread, and human also has an account. Okay. So far so good. Okay. And the boyfriend, right? When he runs, when the boyfriend runs, when the boyfriend runs, what is he going to do? So it seems like it's going to be a pretty expensive night for him. He's going to withdraw how much? 1,000 baht from his bank account, right? Let's see how much the girlfriend is going to withdraw. So how much is the girlfriend withdrawing from the account according to this example? 50 baht. 1,000 versus 50 baht. So I guess I know who's going to be paying tonight.
It's your example หรือเปล่าครับ
So that's what we have happening. Okay? We have, that doesn't reflect the reality. 1,050 baht. No? So when you think about threads, I want you to think of people, right? You have Nat here and Ploy here, and then they have 1,000 baht, 10,000 in their account. And then she withdraws 50 and he withdraws 1,000. Now, the key that I want to emphasize is that both of these accounts, sorry, I should not have crossed that. They're separate. So because they're separate, my question is this. When Nat goes to withdraw his account, does he have to wait for Ploy? Why? Because it's his account, right? How about when Ploy withdraws money from her account? Does she have to wait for Nat? Yes, they're going together, so they have to wait for each other. No, just kidding. No, they don't have to wait for one another because the two accounts are totally separate, right? So let's say that Nat, let's say Nat uses Kasikorn, and let's say Ploy uses SCB. So Kasikorn is the name of a bank here in Thailand, and SCB is another bank, okay? So since you guys are using two different banks, and that means that you guys will be withdrawing from different ATMs, right? You guys don't have to wait for one another then. Is that right? No, you don't have to wait. It's two different ATMs, two different bank accounts. So when I run this application, let's see what happens. Okay, so what was the original balance account? Accounts balance? 10,000, right? Yeah, so they're going on a date tonight. Ploy got her money and she's game for tonight. She has now how much in her account? 9,950. And Nat has 9,000 left. So everything makes sense, right? You just have two threads and each one of them operates on its own data. Two threads, just run concurrently, done. Simple so far, right? You guys understand? I think the key point that I want to point out is that first of all, since the accounts are separate, you don't have to worry about coordinating the threads. And you will remember that when you have a thread, you need to implement the run method. So far, so good. That's the first example. So let's come back to the slides. So we've just covered threads, T-H-R-E-A-D, that class, the thread class. The next keyword, the next concept that I want to cover with you guys is actually a Java keyword, which is synchronized. So who has heard of synchronized or used the keyword synchronized before? No? So I want you guys to remember this picture, right? Synchronized is synonymous with locks. And we'll see what that means using the next example. Oh, I hate it when this happens. Okay, first of all, so I have a next multi-threading application, okay? And I call this the hubby and wifey application. So let's see how it differs from the previous example. Yeah, you'll see the topa, the variable names real soon. So, all right. So now, okay, we have a different situation. What was the previous example? We had lovers, right? We had two lovers, but now we have a married couple. And what do you think is going to be the change when you have a married couple? They're going to have a joint account. They're going to share the same account. So in this case, sharing is caring, right? So in this case, we have a joint account as opposed to a separate account. And we have the exact same situation. We have a joint account whose account's name is Pak and Anon. Anon stands for anonymous, not Anon. No name. And the account's balance is 25,000 baht. We are poor. And we have a husband type and a wife type. And both of those types are still humans too, okay? But let's see the class definition of husband and wife. So what the husband will try to do is that, so he has his joint account with his wife, right? And he's going to withdraw 1,000 baht as the hubby. But, but you see, the husband being the husband, okay, he also checks out other girls when he finished withdrawing the money. So this is right before when he tries to go home. So let's assume that he takes half a minute or half a second to check out some other girls, okay? So that's the behavior of the hubby. And what about the wife? The wife, okay, so the hubby tried to withdraw 1,000 baht for what? Buying dinner for friends. And the wife, she has the joint account and she's trying to withdraw 25,000 baht as the wife to buy her Prada, her Prada bag, okay? So let's see, let's try running this application and see what happens. So you see the problem? Well, okay, I'm sorry, I didn't mean to see the problem. First, I have to visually draw on the board what we have. So what's the one change that we made to the application besides the behavior of the husband and all that? What's the one crucial change we made to the application? Joint account, right? So now we don't have not employed anymore. We have Pak and somebody, Anon. And then we have a joint account, right? So both of these two humans or people or threads need to access the same account. That's the first requirement or the first crucial change we made to the application. And what was the original amount we had in the joint account? 25,000, right? And how much did Pak want to withdraw? No. How much did Pak want to withdraw? 1,000, okay. I didn't hear you correctly, sorry. How about Anon? How much did Anon want to withdraw? For her Prada bag. So if you do the math, if you have originally 25,000 and you try to withdraw 1,000 and 25,000, how much should you have left in your account? Negative. So in the end, you should have negative 1,000. What did we get in our application? What did we see when we ran the application? in parentheses, that's the current account balance that we have left. 24. Is that right? It is right for the husband, for example. I mean, the husband, if he is the first one that withdraws the money, he should have 24,000 baht in his account, right? But what about the wife? How come the wife has 24,000 baht left as well? Something is wrong. Because you have two threads that try to access the withdrawal API at the same time, but because they both need to access or update the account balance, you need to manage the access of the thread. Ideally, what do you want to have happen? What you want to have happen is that one thread access that API one at a time. But if you look at the withdrawal method, currently, okay, let's look at the withdrawal method a bit. Wow, it's really hard to, let me try to close. So here, we have withdraw, and the logic of the withdrawal method is really simple, right? You could, for example, implement it like this. So you have the amount that you're trying to withdraw, and you have the current balance in the account. If the amount is less than the balance, right, then you could withdraw. Otherwise, then you have to print out something to indicate that you can't withdraw because you ran out of money, right? So what do you think in this scenario, if I were to say that the husband will withdraw first and then the wife will withdraw later, what should be the correct behavior? I'm just asking for the amount, the balance in the account. First, we should see 24,000, right, as the balance. And then when the wife tries to come in, she should not be able to withdraw, right? Assuming that you cannot overdraft. So in other words, in the end, you should have 24,000 baht left still. But you should get some message. So how do you ensure that only one thread can come in and access this method one at a time? You use what we call the keyword synchronized. Oh, whoops, sorry. I need to have this right before that. So if I made that change to ensure that only one thread gets to execute that method one at a time, what is going to happen? Let's check it out. Let's try running the program again. So you guys remember the behavior of the program prior to this, right? Couple. And by the way, all the code samples today will be uploaded onto GitHub, and you guys will. So this is more like it, right? This is typical of a husband and wife, I think, well, more or less. Right? Well, since we're going to ISE, we have to read the English version. But this is more like it, right? You have a joint account, and you have two people trying to withdraw the money. The sum of the withdrawal exceeds the total balance in your account. So the second person who tries to withdraw 25,000 should not be able to withdraw the money. And this is why the hubby, when he went in and tried to withdraw 1,000 baht, he was able to. But then when the wife came in, she was not able to, and she had to curse him out like that. How did we fix that then? So one of the key takeaways that I want you guys to understand about the keyword synchronized is that when you put it as part of the method signature, like you saw in this example, when you look at here, human join account. When you have synchronized as part of the method signature, then it will ensure that only one thread will get to execute that block at any given time. And when that thread finishes with that method, then the next threads that were waiting will arbitrarily get to access that account. So that's what the synchronized method does, or not the method, the keyword does. Something's wrong with. Why is it off? So the lack of the synchronized keyword that you just saw earlier, and the behavior, the program that you saw when you did not have the synchronized keyword, this is what we call a race condition in computer science or in multi-threading world. Race condition happens whenever you have two threads that try to access the same resource, okay? But the access was not regulated. In multi-threading, the first rule of thumb, whenever you have threads try to access the resource, one reading and one writing, if you should always only allow one thread to access that resource. Did you guys get that? So in the case of the joint account, as an example, we had two threads that try to modify the joint account at the same time. In those situations, you should ensure that you use something like synchronized keyword to ensure that only one access the account one at a time. Now my question is this: what if instead of withdrawing, both the husband and the wife simply just want to check the current account balance? In other words, they are simply just reading the state of their account balance. In that situation, would you need to have synchronized? No, right? Because you're simply just doing a read. Okay? So if the situation, so in multi-threading, the key that I want you guys to take away is that if all that you're ever going to do with the shared resource is to simply just do a read, you'll never need any locks. You'll never need any synchronize. But if you know that the shared resource needs to be modified by at least one thread, whether it is a read or a write, you have to ensure that you use synchronized in the methods that you have to do a write and a read. So synchronize is the keyword that you use to regulate the access so that only one thread gets to access that particular method one at a time. And so the race condition, formally defined, before we define what it is, I want to talk about the sort of symptoms that you see when you run into a race condition problem. Based on my experience, normally you would see the behavior of race condition is whenever you run your program and it behaves differently each time that you run. Because the one thing about multi-threading, why it's hard, is that it's arbitrary. The behavior of the program is arbitrary because you have multiple things accessing or multiple things going on at the same time. So the symptom that you see with race condition normally is like whenever the program will run differently whenever you rerun it, for example, or when you adjust timing. So if you had like threads or thread sleep in there, or if your program you change the timing of your processing code, okay? And when you change the hardware, so for example, if you instead of running on a single core machine, you ran it on like a multi-core machine, and you see different behavior. By different behavior, I mean a different behavior that exhibits incorrect result. These are all the symptoms of race condition. And the cause of race condition occurs whenever you have two or more threads that are all trying to access the same resource at the same time without appropriate control access. And by control access, here we mean, for example, synchronized. Because synchronized only will ensure that only one thread gets to run at any given time. So that's an example of a race condition. So now that you guys have learned synchronized, I want to propose an example of how you can create a class that will be thread safe. It's really hard to, hold on. I'm trying to zoom in. Okay. Some of this is just best practices for OO design. But first of all, when you design a class to be thread safe, you would want the public fields to have no public fields. You don't want to have any attributes to be public. This is why we say we don't have any public fields. And all fields initialize in the constructor. So in this case, we have identifier as the field, right? So we initialize that by passing in some identifier as part of the constructor. And I think the most important point is that all methods are synchronized. You see that we have every single method denoted with the synchronized keyword. That is to ensure that whichever threads are going to be accessing this class, all the methods, all the access will be controlled by the synchronized method, by the synchronized keyword. And why is it that we want to have no fields to be public? Public versus private. So we have private here. So when it's private, how does that affect the access of the code? Can you do, for example, timing node dot identifier from outside of here? No, right? The reason why we say that no field should be public is because we want to ensure that whoever wants to access those fields must go through our synchronized methods. Is that clear? Yeah? So this is an example of how you could design a thread-safe class. But you see, you have to understand that in programming, all things that you do have trade-off. So in this example, for example, we put synchronize to ensure that we don't have any race condition. What do you think are some of the downsides, associated downsides with using the synchronized keyword? What is the behavior of synchronized? So for example, if I had multiple threads, okay, that, for example, access the propagate update method, if I had 5 threads, without the synchronized method, how many threads can access that method all at the same time? 5. But now with the synchronized keyword, how many can access at any given time? So that's what we want. Good, Nip. So that's what we want. But what's the trade-off what did you lose? Speed, right? In other words, the key that I want you to take away is that even though the synchronized keyword ensures that your program behaves correctly, but the penalty is that each time the threads access the synchronized methods, what you lose is performance. What you lose is the time that all the threads have to wait for. There's overhead involved associated with locking or synchronizing the methods. That's what you lose. Now, so that's the first one. The second one that I want to ask you is that this example is simple, right? You have only what? How many methods that have the synchronized method keyword? 3. What if it's not 3? What if there were 10? That's a really bad design, right? Like a class that has 10 methods, but just follow along with me. What if you had 10? So in real life, and it might not sound like a big deal, or it might sound a bit incredulous, but ensuring that you remember to place the synchronized keyword at the right place, at the right method, actually is quite error prone. As a developer, we have like many things that we have to consider while we writing code. It might look trivial now, like, oh, well, I mean, if you have 10 methods, you just put synchronize in every single method. But that's not true, right? Because there will be some methods that you don't think that you know that you would not need synchronize, and there will be some other methods that you know that, oh, I know I need the synchronized keyword for these methods. But the problem is precisely that. You have to think, right? And I'm not advocating that when you're programming you don't think, but these are what we call tedious tasks that you have to like make decisions. And as a developer, as a library framework developer, this is why they came up with concurrency tools, like newer concurrency tools, newer design pattern, so that you do not have to work at such a low level. So with the new tools, you start seeing that some of these are actually quite tedious. There are ways to not have to concern yourself with ensuring that this method is locked. Again, I'd like to emphasize that I'm not saying that we totally eliminate the need to use synchronize, for example. But with new design pattern, there will be cases where you use synchronize before, but with the new design pattern or new library, you don't need to. And so this is why in the next slide, we have 2 concerns of using the keyword synchronize. One is because performance suffers when you use synchronize in every single method. And secondly is code fragility, where if you forgot to put synchronize keyword somewhere, you will run into race condition, and you have to like make all these tedious decisions to ensure that your code is thread safe. This is what we mean by code fragility. Okay, before we move on to the next slide, since it's 10:30 now, I want you guys to take a break, okay? And we'll come back and take a look at more synchronized example. 11 a.m. By the way, I bought the new Mac connector. Just if you guys remember, I had the problem with the Mac connector. Finally bought the legit one. What is wrong with? I know. Okay, so hold on, okay. So the next synchronized example we're going to be taking a look at is more synchronized example. And today we have honored guests, Pierre and Mederic, as our actors. So let's take a look at what they're going to be doing in our example. If my IntelliJ would finally load up. I'm just kidding. I'm waiting for my IDE to load. That's why I don't know why it takes so long. Normally it takes like 3 seconds. Okay, it's finally up. It is still loading. OMG. I don't even remember what the example is. Okay, so thieves. Oh, I can't. All right, so in this example, the thieves are trying to get the blue and the black label. Hey. So what are the thieves trying to get, Nick? What are the thieves trying to get? Blue and black label. So we have two objects. One is called black label, and the other one is called blue label. And we want to have the thieves try to compete and grab the blue and the black label. So let's see what happens. Wow, so slow. Okay, so Pierre said that he got the black label, right? And then Pierre's trying to look for the other label, which is the blue one. And then Mederic, he ran to the blue label first because he knows that it's worth more. So Mederic got the blue label. I don't even remember what I did. Hold on. Right. So you see, right now, both of them. Okay, let me see if I can explain this correctly. So you guys remember that, okay, if you look at the code, okay, so we have two objects, right? What I'm trying to show you here is another way of using the synchronized keyword. Remember that in the previous example, we had synchronize based on the method, right? Synchronize and then the method name. Here, you actually are not synchronizing on the method. Rather, you are synchronizing on a particular object. So in other words, here, we have the black label being synchronized, and we have the blue label being synchronized. And the point is to basically get to this piece of code, get to this line. So for example, Pierre's objective is to acquire the black label here, and then acquire blue label, and then print that Pierre finally got the elusive blue label. You guys with me so far? If Pierre is able to acquire black label, then this will get printed out. And if he is able to acquire blue label, then this statement will be printed out. So the order for Pierre is black, then blue. Whereas if you look at Médéric, we have blue, then black. So in the best case, since we only have 2 bottles, can both of them acquire both bottles, do you think? and the constraint is that we're going to run them all at the same time. So they're going to have to compete. So let's see what happens. I'm going to try my best to see if I can explain this. So it doesn't, so far what we see is that Pierre got the black label and Médéric got the blue label, okay? And what Pierre is going to try to do next, according to the code, right? So if you're just tracing Pierre only, so Pierre got the black label because we were able to print this out, and then he's scavenging for the other one, and then he found, okay, and then he said, oh, he sees something blue on the horizon, and then he's trying to acquire blue, but then we don't see Pierre printing out anything that has to do with, yes, the elusive blue label. It's not there. So that means that Pierre is stuck here. You guys with me so far? Whoa. No, hold on. I need to take off this, turn off this app. This is what happens. You have too many applications. No. Hey. No. There's also gold label, isn't it? Okay, so what about Médéric? Look at the code carefully. So Médéric is going to try to acquire blue label, right? And then the print statement is, ha ha ha, my precious blue label. And we see that, right? We see that Médéric says, my precious blue label, so he found the blue label, or he was able to acquire the blue label. And then what's next? Médéric is searching for the next one, which is the black label. I don't know why he would want to get the black label now that he got blue, but anyway. So Médéric then prints out here, right? Oh, what's that something black? Get out of the way. So he's trying to get, so he's here, okay? But then we never see this statement printed from Médéric, nor do we see the statement, this statement printed out from Pierre. And the reason why is what we call deadlock. Because you see, at this point, when Pierre is trying to get blue label, who has already gotten the blue label? Médéric, right? So if I were to draw this visually, So we have blue and we have black. So Metric has the blue label, right? And then Peer has the black label. So this is what they are able to acquire for now. But then Metric it's just an abbreviation, so how about this? That's what you get for complaints. So you see, because Peer, so for Metric case, he's trying to acquire the black resource, but who's holding that resource? Peer. Peer is holding that resource because he synchronized on that particular object already. And because of that, Metric is stuck because Peer is holding on to the black resource. Whereas at the same time, Peer is also trying to acquire the blue label. But then who's holding that resource? Metric. And because of that, then you have two threads that are waiting on the locked resource. And whenever you have something like this, when all threads are suspended because they're waiting on some shared resource, hey hoo. Didn't see you earlier. This is what we call a deadlock. Now let's define what a deadlock is, or see the behavior. Whoa. So I think you guys can go study the code example at home later, but I just want to formally define for you guys what a deadlock is. And this is not a deadlock. Okay, the motivating example of the deadlock for computer scientists is that they use the philosopher's problem as the motivating example for deadlock, where they have a bunch of philosophers sitting at the same table and they're trying to eat spaghetti. Sometimes it's something else, but for our example, it's spaghetti. And then in order to eat that spaghetti, you must acquire the forks. But then there's not enough forks for all the philosophers. So what you end up with is that none of the philosophers get to have the spaghetti and they all wait on each other. You guys can look that up. But this is actually a joke where they say that the real problem of the dining philosopher problem is that who's going to pay the bill. And I thought that was funny. But apparently you guys don't think so. Oh, thank you. You guys are so nice. So, see, the reason why I don't like to formally define what a deadlock is, and I'd rather describe the symptoms, because that's normally how you really get to learn what a deadlock is, or what was the other problem that we saw earlier? Race condition. I want to show you guys, or define for you guys, what a deadlock is like. And when you encounter a deadlock in your program, the symptoms that you'll see are, for example, your program seems to just stop. It doesn't run anymore. And when you look at when you launch the Windows Task Manager, you'll see that your CPU, if you're not running anything computationally intensive, is that you see the CPU utilization pretty much flat at 0%. And you know that you have a deadlock problem when you're working on your homework and it's 2 hours away from the deadline. So the third one is a joke. Don't take that seriously. It's just the first two, okay? But that normally is what happens, okay? And what is the cause? Okay, so whenever you run into that problem, when you're working on a multi-threaded app and nothing seems to be running, the cause most likely is because somewhere in your application, you have 2 or more threads again, right? If you only had 1 thread, you can't ever lock yourself. You can, but we're not going to talk about that. But for the case where you have a normal case, when you have multiple threads running, okay, deadlock occurs when you have multiple threads trying to access the scarce resource that others threads are currently controlling. In the case that we just saw, this is an example. You have M locking blue resource, B or P locking black resource, and then M is trying to acquire already locked resource, whereas P also trying to do the same thing. When you have something like that, whenever you have a thread trying to acquire a locked resource that is done by another thread, that is when a deadlock occurs. So if P did not attempt to acquire blue, which is locked by M, and he just kept running, I mean, he would not be deadlocked, but M would be if P never unlocked the locked resource. Okay. So another way to, like the formal definition that I came up with is when you when you have a deadlock, it's like when you have interlocked, indefinite resource acquisition. Interlock, by interlock, something like this, intertwine. And then indefinite is that these two, they never release their lock. Okay? And I think once you guys look at the code example, you guys probably will be able to play around and then internalize the concept in deadlock. But for now, just remember the symptoms. Because if you know the symptoms, then you'll know that, oh, I have a deadlock. So then I can look at the cause. So now that that was like the last example for the primitive tools that I wanted to share with you. So before we go further to the modern tools, I want to just recap real quickly the benefits of using multi-threading in your application, as well as the trade-off that come with it. And the main key or motivation of why you would want to use multi-threading is because it helps improve the performance of your application. But it comes with a cost, like all things. First, you already see that your code is a lot more complicated when you introduce multi-threading in your application, okay? And you see an even more prominent example later down the line in this lecture. And also, your code is now more verbose, right? As opposed to just focusing on the problem at hand, you also have to worry about deadlocks. You have to worry about race condition. But like I said, if you do everything following the best practice, most of these problems should rarely occur. They still occur, okay? But that's just life. That's the trade-off that you have to take. So the question is, now that I've gone over the primitive tools, can we do better? By better, I don't mean the performance gain, because with the primitive tools, you can certainly have the same performance gain as the modern ones. But the question of can we do better here is, can we, as a developer, have an easier time with multi-threading, with better tools, more convenient, and easier to use? The answer is, for certain applications, yes, you can. So let's take a look at the tools that we can use to make our lives easier as a developer. But before that, let me take a 5-second sip. No, enough break. So modern concurrent tools. So modern is something that is characterized by most up-to-date techniques, ideas, or equipments. And in this context, I want you guys to think about the techniques and the equipment. By equipment, we mean tools, the classes that you'll be using for your homework. So why am I teaching you the modern tools? Because we want to stay away from the primitive tools as much as possible. Because by using the modern tools, you don't need to explicitly or directly use the thread class and or the synchronized keyword. And because with the modern tools, then you don't have to reinvent the wheel, okay? Reinvent the wheel, by that I mean there will already be some class in the modern tools that have already been implemented for you. Whereas if you didn't have them, you would have to implement on your own. And code fragility, we already discussed that. And tediousness, we've already seen that as well. For example, having to play synchronized in all the methods. So let's take a look at the modern tools that Java 5 to Java 8 has implemented. But what I want to tell you is that it's not possible for me with about 45 minutes left to cover all the tools that are available to you as a Java developer. There are just simply too many. But what I'm going to do is I'm going to highlight the ones that I feel will really help you as an application developer. And I know this because I actually used something along this line in other frameworks, in other programming languages before. So let's take a look. First one is what we call an atomic class. Atomic classes are basically atomic class, for lack of a better term. By atomic, what is atomic? What is an atom? What's the definition of that? I don't know, is it Greek?
Cannot be further divided.
Right, it cannot be further divided, right? In this context, what we mean is that whenever you use these classes, when you have multiple threads accessing them, the lock has already been provided for you. So let me show you an example so that you get the gist. I like to use that. You get the point of these classes. And the point that I want you to take away from this is that with these classes, you would not need to use the keyword synchronize. Remember, the key for us as a developer is to minimize our usage of synchronize, right? So let's take a look at how we can achieve that. So I have prepared for you an example. So here, it's just a really basic application where you have 5 threads running concurrently, and we have a single number, okay? And all that we're trying to do is to, let me just pause it real quick. And all we're trying to do is to increment, have so we have a single number, a single integer, and we have 5 threads. They're all trying to access. Each time that it accesses this integer, it will increment as well. And then we print out the number that we see. So you access the integer, you grab the number, and you increment by 1, and then you print out. Each of the thread is responsible for printing out the number that it sees. So if you implement it correctly, you should just see ascending order of numbers, right, for the threads. And that's what we seem to see here. So how do you implement that? Well, for example, so let me just walk through the code real quickly. We have main, and we have 5 threads where I just create a new thread, passing it the ID, the thread ID, and then start. So that means we should go take a look at the class definition of counter, right? So counter, it's really simple. We have something that extends from thread with the thread ID, and then we have what we call a safe integer, and we'll take a look at what the safe integer is. But for now, let's take a look at what the thread does. And what the thread does is really simple, where we just have a for loop, right? Looping over 10,000 times. And then this is the number. The number is this number. okay? And then all we're doing is we simply getting the next number, print it out, sleep for 5 milliseconds, and then keep looping over. That's all we're doing for this application. So let's take a look at safe integer, what it looks like. Safe integer is really simple, right? When you instantiate it, it's initialized to 0. And then this is the definition of synchronize, or not synchronize, get next number. If you remember, you saw get next number down here. And all that it does is increments the number by 1 and then returns that value. So for us to make it perform correctly, since we have multiple threads accessing, not only accessing, but also modifying the value, you would need the synchronize keyword. Is that right? Right? So that's all this application is doing. And we know that we want to minimize the usage of synchronize, right? So how can we use the modern tools to help make our lives easier if we want to implement this example using the modern tools? We can, for example, replace safe integer class with atomic integer class, which is provided by the Java framework. So let's take a look at that example that I have prepared called atomic. Let's start from the bottom. So we're going to go through the application again to see the changes that I had to do, that I had to make use of the modern tool, which is atomic integer. So we still have main, right? And we still instantiate 5 threads or 5 counters. And the thread definition is exactly the same, with the exception of instead of get next number, the method has now been changed to get an increment. And if you look at the number variable type, you'll see that it's atomic integer, where you have to import Java util concurrent atomic integer to be able to utilize this class. So you see the difference. And how do you initialize the value? You initialize the value by passing to the constructor the initial value you want for that atomic integer. So what are the differences that you guys can see from this example compared to the previous one? The most obvious should be pretty obvious. Auntie, what do you think is the difference comparing this example to the previous example?
No synchronize.
Okay, well, no synchronize, that's the key to this slide. What else?
Counter.
Right, so our counter, the number, we changed from our own class that we had to implement called safe integer to be atomic integer. So in the previous example, I had to create my own class called safe integer. But here, I simply am reusing class provided by the Java framework, or to be more precise, Java concurrent framework, and that is atomic integer. Those are the main differences, right? First is that we don't need to use synchronize anymore. And second is that we are instead using classes provided by the Java framework. Why would we want to reuse something that other people develop for us or provide for us? What's the benefit? Why not just, in this example, why don't you just implement your own 3-line class called safe integer? Why do we want to use atomic integer? You already see that it doesn't really change the line count, right? The code is pretty much the same in terms of the number of line counts. So why would we want to use something provided by some other people?
Don't want to reinvent the wheel.
Exactly. So the key is that we don't want to reinvent the wheel. We want to reuse. As an application developer, if you could choose between implementing your own and reusing some other people's class, I'd say that for the case where it makes sense, you want to choose to reuse some other people's work. Why? What's the benefit of not reinventing the wheel? Do you think? Hmm? You get to use the wheel other people make? Did you say that? Why? But why? Okay, let's apply to this particular example. Why should we want to use the Java concurrent atomic integer as opposed to our own safe integer? What's the benefit?
It can take care of synchronize for us.
Okay, it can take care of synchronize for us.
Universal.
It's universal.
It avoids our mistakes.
Exactly. I think the key, well, at least for me personally, you guys might have a different view. Whenever I have to implement something by myself, I say 10 times out of 10, I would end up making a mistake. And I would have to spend time debugging the code that I just developed before it can actually be used reliably. So from my point of view, the reason why we want to reuse is because, first of all, we don't want to have to debug the code that we write, right? So in this particular example, for example, if in the case of the safe integer class that you saw earlier, if you forgot to include the keyword synchronized, then your program will not work correctly, right? So that's one. And secondly, not only that by reusing we avoid the mistakes that would have happened had we used our own class, but also do you have to waste your brain cycles to try to solve a problem that has already been solved? In this particular example, we wanted a class that would allow us to declare an integer that is thread safe. And the answer is already there. It's atomic integer. Why do we need to know about synchronize? Right? Why do we need to create our own class? So being able to reuse also saves you time. From another point of view is that you don't have to waste time debugging your own code, and also you don't have to waste time developing your own code. So those are two things that I think are really crucial for reuse. But there actually are other benefits as well. Case in point, atomic integer versus safe integer. If I were to walk up to you and say that, hey, would you like to use my safe integer class, Jompot? Jompot would be like, okay, I can use it, but what does it do? Compare that. So he doesn't know what safe integer does, right? But compare that to, hey, Jompot, I have a class called atomic integer. It was from the Java doc. I mean, you can look up the Java doc. It was provided by the Java concurrent util package or whatever. You don't have to explain anything more because Jompot, he has a computer, he has the internet, he can look up by himself the APIs that come with atomic integer. So to summarize, the benefit of reusing code is that you don't have to write your own documentation, right? Documentation is crucial, whether it is in the form of an official documentation on the internet or as a form of test. You can actually have tests, right, that will document the behavior of your code as well. But let's just focus on traditional documentation where it's just on the internet, like Java doc. So you see the saving. So you save time, again. Save time from what? Save time from having to explain to your classmate, your coworker, the code, how to use the code. Because that part has already been provided to you by the Java framework developer. Is that clear? So the key, what is the key then in terms of reuse, is to save time. But that time, when we say time saving, it can be expressed by in multiple perspectives, multiple aspects. Save time from developing, save time from debugging, save time from writing the document for that class. Is that clear? And multiply that, right? We're talking about just one example, safe integer versus atomic integer. What if you had to reinvent the wheel, thousands of classes. You can imagine how hard it's going to be to work with someone, right? So I hope you guys see the benefit of reusing the code. So for this homework assignment, before you get started implementing anything, okay, I want you to take a good look at the existing libraries, frameworks, what have you, that people have already provided for you in the Java community. And in fact, one of the selling points of why the university might want to choose a programming language like Java as opposed to, there are some other esoteric or less well-known programming languages like Scala, Ruby, or I don't know, D. The reason is because I'd say that most of the universities in the world use Java as their main instrument for conveying programming language knowledge. And when you have a lot of people using the same thing over and over, not only that bugs are squished, right? They're eliminated, but also because I bet that most of you, when you did your homework, you Google a lot of code example, right? I bet that it's a lot easier to find existing code example using Java as opposed to using something like D, the D programming language. There's supposedly the successor of C++ programming language called D. I bet that if we were to, for this class, change the main programming language from Java to D, I think that you guys will have a harder time trying to find examples on the internet. So I want to just convey that point to you guys that reusing is not just, it's not, how should I say it? It's not applicable to just libraries, okay, and classes. Actually, I think it's applicable to all things in life. This is why people would rather take the tried and tested path as opposed to the unbeaten one, the new paths, right? Because when you follow the path that other people have walked before, you have an easier time because people can, they can clean the path for you, right, by providing you with the relevant classes that you can reuse, okay? I digress quite far away and we are just like halfway through the lecture. Oh my God. So that's an example of atomic integer. So let's take a look at something else. Countdown latch. Okay, I'm going to leave this slide up a bit, but countdown latch. Countdown latch. When you see the word countdown latch, I want you to think about thread coordination. I want you to remember that well. Countdown latch as a class is a Java class provided by Java concurrent util again. It is a class that allows threads to coordinate the work with each other. Let's take a look at how do you coordinate the work. We are going to relive the, what is it called? iTaste night. All right, so here's an example. We have 3 people again, 3 humans. We have drinker number 1 is called Niran. We have Tong as the second drinker. And then we have the third drinker, Pak, yeah? And they all share the same countdown latch of called one shot to rule them all. And what we're going to do is we're going to ask each of the drinker to drink it up, okay? And let's see how long they'll last. Now, let's just go through the example and I'm going to explain to you the countdown latch This class is provided by the Java framework. It's the only class in this example that I didn't implement, okay? Drinker I implemented. You guys should know already that start indicates that this is the thread, and I already showed it here. We are going to ignore this countdown latch, the behavior, what it does. But for now, think about this. Remember the night of I taste? The Frenchies, you guys didn't go, but that's okay. I think you guys will understand the concept anyway. So we have 3 drinkers. We want them to compete to see who can drink more, okay? Before you can make the decision of who can drink more, you have to wait for all the drinkers to finish, right? Agree? You can't, like, if 2 finished and you can't just like, oh, well, those 2, the guy that finished last or later, he is the winner. You can't do that. You have to wait for all 3 drinkers to finish. And the first thing I want to point out is the await method on the countdown latch. Because this is the method that we use to wait for all these 3 threads to finish executing, okay? And let's see what happens. Oh. So we're done drinking it up. Now we don't know how to get home. Okay. Oh, well, see, this is wrong right here, right? Because if you guys notice carefully, okay, we have this system.out.println that is printed after we've waited for all the drinkers to finish drinking, right? But do you see how, like, first, we already get this printed out. So that means that the program is not behaving the way we want. In other words, await did not wait at all. Do you guys agree? Because here, these print statements, these got printed by the threads. So let's go take a look at the run method. In the run method, what do we do? We drink it up, right? As a drinker, we drink it up, and then that returns us the number of seconds he was able to drink. We pass the number of seconds to a method called what kind of drinker are you? Based on the number of seconds, then we'll get the kind of drinker that he is. And then we print it out. And then the countdown latch I'm going to talk about later. But it is a mechanism for us to signify that, oh, okay, this drinker is finished drinking. But I want you to come back and pay attention to this. What we really wanted for the application to do is to print this out, this statement, after all the drinkers have already finished. But you see that the incorrect behavior is that it gets printed like the very first thing. So that's the bug in this application. And how you fix that is we have to make sure that we initialize the countdown latch properly. My question is, how many drinkers are there in this example? 3. So I'm going to initialize the countdown latch to be 3 because, and let's rerun the application again to see what happens. Now, are you guys convinced now that the program is working correctly? Because we have 3 drinkers, right? And this is probably the best perfect example because Niran is a wuss, Tong is a hero. Well, no, I mean, it's supposed to be switched. No, but I'm the best because I was able to drink for 20 seconds straight. But anyway, coming back to the main point, now the program behaves correctly because what I wanted was to run the threads, the 3 threads, wait for them all to be finished, then print out that, okay, we're done drinking it up, now we don't know how to get home. So how did I make the program behave correctly? If you guys were paying attention, you'll see that the only change that I made was the countdown latch. I changed it from 0 to 3. And now it's time for me to explain to you how the countdown latch works. You see, countdown latch is very simple. The reason why it's called countdown latch is because initially you tell it how many threads you're supposed to be working for, waiting for. In this case, we want to wait for how many threads? 3. Okay, then what happens? The await method, okay, will not unblock. Do you guys understand what I mean by unblock? So by unblock, I mean this condition, this statement will not be done executing until the countdown latch has been decremented to 0 or less than 0. So tying this to this countdown, whenever a thread calls countdown, it will decrement the initial count by 1. So in other words, we have a countdown latch whose original value is 3, and since we have 3 threads, okay, when all 3 have called the countdown method, then the countdown latch will be 0, right? And once it's 0, then await will unblock, and then you see system.out.println. Does that make sense? So if I were to change this to be 1, what do you think will happen? What do you think will happen if you change it to be 1? It will only wait for 1 thread. And what do you think will be the behavior of the program if I ran it? Let me just run it. Do you think we'll see done drinking it up? We will, right? Because you see, the await will only wait for 1 thread. But we have 3 threads, right? So when one of the threads called countdown, right here, this await will unblock immediately because, like I said, await will only unblock when your count is 0 or less than 0, right? So how do I prevent this from being shown at all? You would initialize the count to be something that is more than 3 because we have 3 threads that are decrementing, right? So let's see what happens here. Do you see it now? Because await does not unblock, like I said, until you have reached the 0 count. But we initialize it to be 4. You see that? We initialize it to be 4, but how many threads do we have decrementing? 3. And because of that, that is why await did not unblock. So what's the usage of countdown latch? You want to use the countdown latch whenever you run into this situation. It's not only applicable when you have people drinking, okay? Let me generalize that. So that was just an example. But a good example of a countdown latch is when you have something in your application running sequentially, and then suddenly you actually have to have multiple threads doing something concurrently, okay? And your program cannot keep going until all these threads are finished with the task that you want. In that situation, you want to use something like a countdown latch. So in this example, you have 5 threads, right? So you want to initialize the countdown latch to be what? 5. Because you want to wait for 5 threads to finish the task. And then each one of them will call the countdown, right? The countdown method. And when all of them have called the countdown, then the main thread that initiated this parallelism can then unblock and keep going. So in other words, countdown latch is a good tool to use when you want to wait for multiple threads to finish their task. And we'll see, is that clear? The concept is very simple, but the application is quite profound because now you guys have all the tools that you need to understand the first multi-threaded design pattern that I want to introduce you guys. And we call it master worker pattern. Ping, Nit, what is the first design pattern that I want to introduce to you guys? That's not the design pattern. Football? What? No. So what was the first design pattern that I just mentioned right before I asked them questions? No. What was it, Niran? Oh, it's called. Oh, I messed up. Oh, you guys ruined it for me. Well, I just call it master worker. But hold on, before we talk about the master worker design pattern, I want to mention real quickly. So countdown latch, the takeaway. Like I mentioned, right? It is a tool, okay, a modern tool that you use to synchronize n number of threads, where n is the number that you pass into the countdown latch constructor. And the three important points to remember is that the constructor's parameter n is the number of threads you want to wait for. Secondly, the method countdown is the method that you use for each thread to decrement the count. And lastly, the main thread, this is the guy that's going to be calling the await method. And the use case is the master worker design pattern, which if Ping and Nit was actually listening, then they would be able to answer, as opposed to giving lame answers like atomic, thread, and what have you. Okay, so what kind of master worker are we talking about? Are we talking about this kind of master and worker relationship, where you have the master, and then you have the worker? So I want to first describe to you the master-worker relationship. What do you think I mean when I say master-worker relationship? Can you guys guess why we want to study this design pattern from this diagram? Yeah, it's slave. Okay, so when you have slave-master relationship, what is the key? What is the description of master-slave? What's the benefit of having a master-slave relationship? Okay, one master, and then what? What will the workers do?
Follow their order.
Follow the order, right? So the master will have some sort of order, and then you distribute that order among your slaves or your workers. In this case, for example, we have how many workers? We have 5 workers. And how many masters do we have? Okay, and then what are the works that the master distribute to each of the workers, starting from the left-hand side? Okay, I mean, okay, for this, is the avatar face, does that remind you of something? Right, so in this case, I'm trying to convey that the master distributes homeworks to the workers, okay? And then the result that gets returned actually is supposed to be the finished homework, right? But in this case, I'm just writing down the grade that you got for that homework assignment. So that's the kind of, so I want you to keep that in mind. The key takeaway from this slide is that typically, you have one master who knows all the work that's supposed to be finished, and you distribute. As opposed to the master doing all by himself, you have workers that take the order from the master, does the actual work, and then return the result. That's the gist of master and worker design pattern. Let's take a look at an example. This is a real-life example, and it's the most important example for this lecture. If I ask you to sum up 100 numbers, my question is not how would you sum them, but my question is how many different ways can you sum 100 numbers? Give me the first naive answer.
Google.
All right, that's one, but we're not going to talk about that solution. Okay, you can Google. Imagine let's say you were sitting in the exam room, and I asked you on the problem, I gave you 100 numbers to sum. How would you sum them? Yeah. Okay. No, it's 100 numbers. It's not 1 to 100. So you're given 100 numbers. How would you sum them? Sum it yourself, right? I mean, that's the first. I mean, that should be pretty obvious. I mean, you know, you're in the exam room. I ask you to sum 100 numbers. The first solution is do it yourself, right? You can sum the numbers yourself. Can you not? Right? DIY. Non-contained solution. The Frenchies and Tato and Auntie, you don't have to remember. I mean, you don't have to understand the NONQEA. That's not related to what you need to know. The Thai students get it though. So let's learn Thai a bit. Guan is to stir. Guan is to stir. And Teen is what? Foot. When you stir someone's foot, then what happens? You get kicked. So it's a Thai term. So don't stir somebody's foot. The Thais don't like it. That's so lame. All right. So second possible solution. Now, if I were to ask you, okay, look, okay, these four. If I were to give you the assignment, I give you 100 numbers to sum, and I said to you, M, that you also have those three. How would you sum the 100 numbers? Remember, we are talking about concurrency. The first solution was to sum it yourself. Now, I changed the constraint, and I said that it's a group project now. I give you Sai, Josat. You are actually being tasked to sum 100 numbers now together as a group. How would you sum the numbers? Oh, actually, I should ask Kun Prathan,ท่านประธานนะ how would you sum the 100 numbers given, you know, given that you have 4 team members as opposed to 1? Right? So that's what leads me to the second solution. See, I just knew that she would be able to answer quickly. Teamwork. You want to just split the work evenly among your team members, no? Oh, it shows kind of bad on the slide, but you just want to teamwork and split the numbers evenly. So in the case when you have 4 team members and you have 100 numbers, how would you split the numbers, Sai? Okay, so 100 divided by 4, so how many numbers? Huh? 25. So you would give 25 to M, 25 to Both, 25 to yourself, and 25 to Josette. Assuming that what? That they have like the same mental math capability to add numbers. Because, for example, sorry, Sai, but suppose that you are really terrible at addition. Should we give you the 25 numbers?
Yes, easy 25.
Maybe we just want to give her 2 numbers, and then you guys split among the 98 divided by 3, right? And that leads me to the next solution. Because as opposed to dividing the work evenly, right? You can start off with that. But the last solution is that maybe M is really fast at adding numbers, okay? And then he already finished his 25 while you guys are on like the 5th one. What can M do? What can M do? Okay, so one way he can sleep and he can drink, but if you want to finish adding the numbers quickly, what can you do? Help. So maybe you steal, right? Or you will take away 10 numbers from Both, 10 numbers from Sign, 10 numbers from Josette, and then you add the 30 numbers while they're still struggling to do the addition. So that's the third solution. And in computer science and multi-threading, we call this work stealing. In other words, the competent threads, the threads that execute faster than other people, right, will steal the work from other people, right? Because you see, in multi-threading, and this is precisely related to the reality, right? suppose that you had 3 cores, okay? And this is the amount of work that you have to do for each thread. And suppose that you had 3 threads that work on these 3 tasks, 3 works concurrently. If this is T1, T2, T3, and suppose that T1 is finished with the work, but T2 is here and T3 is here. What you don't want to have happen is that you don't want the resource here to go wasted. This is why if the work can be split further, you have this concept called work stealing, where the thread that is idle will start operating on the work that has not been finished. Is that clear? So I want you guys to remember this well, work stealing. And now let me show you the implementation of how you could implement work stealing. And this is what the Java library does as well. How much time do you have left? You'll be here for a while. One of the class that I will be introducing to you guys today is concurrent queue. What is the class that I'll be introducing to you, Pink, today? Concurrent queue, thank you, Niran. Now I know who's going to be acing the final. I want you guys to pay attention to this because this will be related to your homework. So if the producer is the guy that will be supplying these 4 guys, the 100 numbers, then you can push. So this is a queue, okay? Concurrent queue. And you can have the 4 guys simply just extracting from the queue, pulling from the queue each of the number. And each of these guys simply just sum up the numbers. So in this, if you design it like this, then in effect, you're basically optimizing your design, right? Because suppose that this guy is the fastest, then he'll be the guy that pulls from the queue most frequently, right? You guys follow that? Yeah? So this is one way where you can implement work stealing, is that each of the element in the queue represents a single unit of task where each thread can execute concurrently. And then it doesn't matter which one works faster or works slower. Whoever finishes will pull from the queue until we don't have any more work to be done. Is that clear? This is how normally people implement work stealing in multi-threading environment. So let's take a look at code example. Let me see. I want to check out how many. Yeah, I don't think we're going to get to cover the advanced topics today, which I wasn't planning to anyway. So let's spend our time and effort looking at the most important example of today's lecture. And this one is I'm gonna stop. I'm gonna change to like the spare now. Maybe it will help quiet you guys. All right. So you guys remember the 3 solutions? Okay, the problem that this example tries to do is to simply sum up an array of integers, find out the sum from the array of integers. So what I just drew on the board is an array of integers, okay? How would you write the code to sum up this if you did not know multithreading? This is the array of integer. How would you sum up the numbers? if you did not know anything about multithreading? For loop, right? You would just have a for loop. You would simply, so if you wanted to sum up the number, right, you would have the accumulator. So by accumulator is just that single number that will hold the sum. And then you just loop through. Use a for loop to loop through the data array, sum them up, and then just print it out. Simple, right? So that's the first solution. Remember when I said, if you were given 100 numbers, how would you sum them up? Well, first solution is just sum them up yourselves. Don't have any friends. Is that clear? Okay. Now let's take a look at the second solution. What was the second solution? Share among your friends, right? Tanatan, right? Okay. So let's take a look at how you would implement the second solution. It's a bit long, but bear with me. So in Java, the Java concurrent util provides you with something we call executor. But for now, I'm not going to define what executor is. Let's just look at the code let's just look at the overview of the code. And then you have an array of integer that is the same as the sequential one, right, from the previous example. This is the array that we want to sum. And then this system.nanotime simply just is for the timing. So we can forget that for now. So at time, if we know that the data size is this, and we know that we have n number of threads, well, I guess I'm not going to ask you. So to figure out, just real quickly, if this is the integer array, and you know that you have 4 threads, and this is n, to figure out the even partition, you would simply just do n divided by 4, the number of threads, right? That would yield the length m. You agree? So that's how you would partition the size. If you know that your data is some size, this could have been data.size as well, but I messed up. But anyway, it doesn't matter. So you know the data size, you know the number of threads that you're running. So to figure out the partition size, it's simply just data size divided by number of threads, right? Now here's the gist. You have to distribute the work evenly among each of the workers. So we have the workers, okay, an array of them, a linked list of them, and then you go through each worker, and then you basically create a class that will sum up the data partition. So you have to specify from and to. What is from and to visually? From and to visually is like this. If this array is 100 long, right? You want to split it up among 4, so that means that the partition size m is 25, right? So that means that if you look at the array index, it will go from 0, 24, 25th to 49, 50 to 99, right? This is the from and to, because essentially we're passing the entire array to each of the worker, but we tell it from where to where you should start summing up the elements. So just bear with me, okay? We're just going to keep going. So you have the workers, okay? Now you have the list of workers. You have prepared them. And then to tell them to start, what method do you use? You use invoke all. Invoke all takes a list of workers that you want to invoke. When you invoke all, the result that will be returned is of type future. And the type here is whatever that the compute method returns. I'm going to show you the implementation of some task executor later, but essentially you agree with me, right? That we're not done. Because when you finish summing up the numbers here, so let's say that if this is 58 is the sum, this is n, okay, A, B, and C. You still have one more step, and that is to have the main thread sum the 4 numbers together. You agree? So this is why, in the end, you have to loop through the result that is returned by each of the thread, right, which is contained in results, sum them up, and then you can print out the answer. So I think the missing, in my opinion at least, one of the things that I have not explained to you is the class future. So you agree that in this example, we are trying to sum up integers, so it makes sense that it is something of type integer, right? Future integer. So what is a future? Let me define for you precisely why you need a future class by explaining it visually. Because in our example, right, we have 100 numbers, we have threads, we have 4 threads, so that means that the partition size is 25. We know that we're going to have 4 threads running, and each of them will get 25 numbers. The key of concurrency is that you don't know when the threads will be finished. And because of this, the library author, they don't return you the integer. They return you future object. And this is why we needed to learn generics before we can talk about something like this. Because you will remember that this is generics, right? The reason is because when you get a future object, you get it right away. In other words, when we look at the code here, the results list of future integer, the invoke all returns immediately after the threads have been started. So what's happening is that the threads are currently running, and it comes down here. The code keeps executing and get to here. The get method is the key. Do you guys remember the countdown latch? Remember how the await would block until you get the result? Same thing. The same behavior happens with the future class. In other words, the future integer of the first one, Ja. Oh my God. Get, this get is the key, is the synchronization point, because get will not unblock until it has summed up the 25 numbers. Is that clear? So in other words, I think that there's a method provided by future to check whether or not the thread is still running. And if you call it immediately, right after this statement, okay, maybe you call result is still running, most likely if the numbers were long enough, it will return true because it's still summing up the numbers. So get here will block until the first thread finishes. And then you see you loop, and you go to the next future of this one, this one, this one. In the end, when you call get on all the workers, that is when synchronization is completed because you know that all the threads have finished the computation. Is this clear? I'm trying to explain to you why you need to use future. No, not why you need to use future. Why is it that when you call invoke all here, it doesn't return you the integer? Because conceptually, intuitively, we would think that it would return you a list of numbers to sum up, right? But it doesn't. It returns you future. And precisely why it needs to return future is because of this reason. You have multiple threads running. You need to wait for all of them to finish before you can go on and sum up. Everyone understands that, I hope? You get that?
It can only wait for one thread or wait for all.
Excellent question. If you look carefully at the for loop, we're actually traversing through each element in the array. So in other words, the get only waits for one thread. There's one future for each thread that got invoked. in other words, if we, for this example, we had 4 threads, there would be 4 futures. You have to call get 4 times to wait for each of the worker to finish summing up. Is that clear? So let's look real quickly at the class that we passed to the executor, because invoke all simply just takes an array of work sum task executor, right? So let's take a look real quickly. To implement a worker, okay, is really simple. You just instantiate a sum task executor and you just implement the callable interface. But you have to tell it what is the type that you are expecting to return from as a result. In this particular example, we're summing up numbers, right? This is why we need to pass the integer class as part of the callable generics. And why is it integer? Because this type has to match with the call method. See, this is very similar to implements runnable, right? Implements runnable simply forces you to provide the implementation, the run method. When you implement callable, this is why you need to have to provide the implementation for the call method. But the difference between callable and runnable is that callable also forces you to provide the return type. Ja.
I find something. He ate your friend.